Okay.
Now showing full screen.
Okay, please. Yeah.
Yeah, okay. A very good evening to everyone who all joined for this TIECONN 10th webinar. So TIECONN is a technical innovation and engineering collaborative network. So we will just move into simple. First, we will just talk about the introduction of TIECONN. That's our first agenda. And the agenda 2 will be our vision and mission statement. And agenda 3, we will just meet our leadership, executives, and country leads. And agenda 4, that's our webinar today. So we will just go with the brief of speaker's introduction. So about us. So TIECONN, as you know, it's a technical, innovative, and engineering collaborative network. It is a global initiative led by industry professionals built to uplift the engineering community through technical empowerment, innovation, and collaboration.
Yes, Nabil.
Yeah. So with the growing network of engineers, designers, consultants, and students from the Middle East, India, and beyond, TIECONN serves as the hub for the technical webinars and expert panels. They are giving career guidance and mentorship. Even they are providing engineering knowledge exchange. So that's about the TIECONN. So this is our vision statement to become the world's most trusted and collaborative engineering platform where innovation, knowledge, and the community converge to shape the future of MEP and technical industries. This is our mission statement. We actually started TIECONN to empower young professionals by organizing high impact webinars. Like today, we are conducting one, training sessions, technical events, and technical workshop, and to foster sustainable design, smart engineering, and global best practice through collaboration across borders, and also to celebrate excellence by recognizing and supporting technical achievements in MEP, HVAC, and facility management industries. So these are our founding members and committee members, Mr. Nagarajan, Mr.
Nabil, slides
Victor.
are moving. Are you
Yeah,
moving the
slides are
slide?
slides are moving.
Anyone has same issue? Because I think the slides are
No,
same for me.
slides are not moving.
Yeah, the slides are not moving.
Now can you see my screen?
Yeah, yeah. You can set the
Yes,
screen again.
yes, yes.
Now okay. Now again.
Now it's okay.
Yeah, now
Yeah,
okay.
now
Yeah,
Yeah,
yeah.
sorry for the inconvenience. So this is our committee members, Mr. Nagarajan, who is the speaker today, and Mr. Victor, Mr. Raghavan, and these are all our executive leaderships. Vice President is there, membership chair is there, Mr. Yunus, Mr. Nitesh, Mr. Miss Roshna. We welcome you all. So these are also our country leaderships, executive leaderships. So these are all our country chairperson, Mr. Bahruddin, Mr. Mohammad Rashid, Mohammad Azhar is there. Again, country vice chair. They are all from KSA. As you can see, they are all from spreaded all over the Middle East. Even India, Ashwak from India is there. And this is our technical advisory and award team. Uh, so this is the youth and student division. They mostly take care of the student sides. They are providing mentorship and leadership opportunities, and they conduct educational events as well. So these are our event organizers, Mr. Vigneshwaran, Mr. Murad. So this is our media and communication team. So today, this is our session leader, Mr. Nagarajan. He's a chartered engineer with 12 years of experience in all over Middle East project. He have very good experience in high-rise buildings. So today webinar is about designing and installation of plumbing systems. So as you know, designing and installation of plumbing system in super high-rising building is a complex task involving multi-level coordination, pressure management, etc. So in this webinar, Mr. Nagarajan will share challenges for super high-rise project along with practical solution, critical design consideration and installation strategies. So I now hand over the session to Mr. Nagarajan. Sir, you can continue.
Yes, so I will start sharing my screen. Can you stop sharing your screen? So I will start.
Yes, yes.
Yeah. So can you see my screen? Any issue?
Yeah, it's okay.
Yes, we can see.
Yeah, it's basically.
Yeah. Okay, fine. Just a minute. Okay, so good morning, good afternoon, and good evening to everyone, depending on where you are joining us from today. Welcome you all today to the one of the important webinar, key ideas and installation for the super high-rise building. So as you know that when it comes to super high-rise building, we will have to face lots of challenges compared with the other projects. So today we are going to see the important ideas, the key ideas that we have to consider during the design and installation. So we'll start with our plumbing system first. So as you know that when the plumbing system fails in the building tenants will suddenly becomes an expert plumber with the free advice. So similar to HVAC and firefighting, it is the duty of the plumbing engineers to design and install the plumbing system in a safe, efficient, and sustainable way. So I promise there is no exam at the end. But still, please pay your attention. So let's start with our first important thing. You can unmute your mic for a second. I have a question for you. So my question is like, when operating the high-rise or super high-rise building, what do you think are the main practical challenges faced on day-to-day basis? Anyone? Can anyone answer? What is the day-to-day challenge we will face in the plan? Sorry, again? Okay, okay. Next.
Maintain
Maybe smell on the
faucet
room.
pressure.
Okay, yeah, okay, that's correct. Yeah. Next. Anything else?
Maybe smell comes in
Yes,
the
that is one
bathrooms
of
or something.
the important thing. Yes. Anything else? Yes.
Unusual pressure.
Unusual pressure management. Okay. Anything else?
Energy losses.
Higher velocity.
Higher velocity. Okay, fine. Yeah. So as you told, it's correct.
Also,
Yes.
one more
Yes.
thing,
Yes.
maybe high-rise building, maybe FCU CDP leakage, maybe ceiling damage like this.
CDP. Okay, fine. Okay, so as you told, there are many reasons are there, like the higher velocity, the blockages, the foul smell. So we are going to highlight today these key challenging ideas with some standard backup. So I have taken some reference from the British Standard, International Plumbing Code, Uniform Plumbing Code, and UAE Code and Saudi Code. I have covered whatever I can finish in 1 hour to try to give the maximum I can do in this today webinar. Okay, so starting with the first thing, I'm going to start with the water supply system today. The main thing for every design is the over design or under design. So that is a major problem in every design. So for example, we need to size one water supply tank for a office building. Let's say we have an office building. I need to size one water supply tank. So the first thing we need to consider the how many number of people I need to consider for the design. So that is a key point for all the design. So I have given one simple layout for you. Here in this building, you can see there are some permanent chairs are there. Just a second. I will just take the sticky. Right. So in this one, you can see when it comes to the office layout, there are some meeting rooms are here, and we have some like the visitors chairs are there. So when we consider the number of people for the plumbing system design, the biggest mistake what we do normally in our case is like we are adding the people of the visitors, we are adding the people of the meeting room people, and we are adding everyone along with the permanent chairs. So this will increase the quantity of the number of people, and based on that we are sizing the water supply tank. This is called as a over design. So how to consider the proper sizing? So normally what happen in every project, when we go for the concept design, the very first thing, the concept design, then we go for the schematic design, then we go for the IFT issued for tender, then we will go for the detailed design, then we go for the IFT, IFC. There are plenty of design stages are there. So when we go for the concept design, maybe our ID team, they might not have finalized the ID layout inside. So that time, what we can do, we can follow the standard. There are plenty of standards are available. From there, we can take the number of people. Okay, so for example, the screenshot what you see here is from NFPA 101. So you can see this highlighted portion in yellow. This is the business use. So what they have mentioned as a business use, 9.3. The left side is 100. That is feet square per person. And the right side is 9.3. So what they mentioned here 9.3, we need to consider 9.3 meters square person per one person. So if you have 100 meters square, so you can consider based on 100 meter, you can multiply with the same one. Okay, so this is for the business use. This one you can follow NFPA 101 when you go for the initial concept design. Otherwise, you can follow the ASHRAE 62.1 also, like you see in my design in this screen. This is the ASHRAE table. And here also they have mentioned for 100 meters square, how many people you need to consider. So initially, I showed you that NFPA 101, they have mentioned for the business use like office building, you need to consider 9.3 person per meter square. So here, for example, if you go to ASHRAE table, what they have mentioned for 100 meters square, you need to consider 5 people. Okay, so this is the very first thing we will consider when we go for the concept design. But we go for the later design, we will follow the exact ID layout. We can find out how many seatings are there. I mean, the permanent chairs are there, how many temporary chairs are there, how many meeting people are there. So what I recommend you, in order to avoid the over design, what strategy I normally follow in every design, you need to count the permanent chairs. You need to count all the permanent chair first from the layout. After that, don't add the visitor chair and don't add the meeting chair. So there is a example will come to your mind. So the meeting people also will use the toilet room. They will also consume the water. If you are excluding all the meeting room people and a temporary chair, so that will not be a logic. Yes, I understand. But the actual thing is, when the meeting is happening, for example, when the meeting is happening, all the people will not come from outside. We have an office building. For example, we are conducting one MEP meeting. The MEP manager, mechanical engineer, electrical engineer, all these people, I mean the permanent seating people also will attend the meeting. It is not like all the people from outside are coming and they are only attending the meeting. So we don't need to consider 100% all the meeting chair as it is. Instead of that, the concept is like you can follow maximum 20% of the meeting chairs and the temporary visitor seating. For example, if you have 50 people, the permanent chair, you can consider 50 people. Then if you have 20 chairs, meeting chair, then 20 visitors, so total 40 temporary. So in the total 40 people, you can consider only 20%. So that's more than enough. Okay, so that is the logic we follow to avoid the over design of the water supply tanks. So this is one of the first and very basic of plumbing system. Then this is for the office building I just talked about. Similarly, we have the multiple arrangements are given, like a hotel and other rooms are given. You can follow for the initial design, you can follow the ASHRAE and also NFPA 101. Both standards are is easy for you to refer. Then coming to residential application, what normally the practical thing is like if you have the bedroom, we normally consider 2 people, and for the living room, we consider 2 into number of bedroom plus 1. So this is the concept, because the important thing is if you have the office building, the probability of visitors using the toilet is very low. But when it comes to residential building, for example, if we have some visitors, there is plenty of chance that the visitors will stay in the residential building and they will use the toilet. So it will consume more water. So we cannot simply skip any visitors. So when we go for the design itself, we have to consider that safety limit in our design. So if you have, for example, if you have 2-bedroom house, 2-bedroom, you need to consider 4 people. For that, if we have a living room, 2 into number of bedroom plus 1. So if you have 2-bedroom, 2 people for each bedroom, that will make 4. Then you have the living room. So 2 into number of bedroom plus 1. So there will be 5 plus 4, total 9 people we have to consider for the residential application. So this is how the very beginning of the water tank design we need to consider to avoid the oversizing. Okay, then coming to the tank storage capacity. So okay, now we know we got the answer how many number of people we need to consider. How many days the tank storage should be there? So this will not, there is no international standard. For example, if you go to international plumbing code or uniform plumbing code, they will not exactly tell you how many days of storage you need to consider for your design. This is normally come from the project specification developed by the client or the local standard. For example, if you go to UAE, the Abu Dhabi has a regulation, Dubai municipality has a regulation. If you go to Qatar Karama has a regulation. So for example, if you consider the Abu Dhabi requirements, the total storage capacity of the ground tank and the roof tank shall be the following limit. What they are telling, the minimum capacity you have to consider 1 into daily consumption plus firefighting reserves. That means, for example, if you have 50 people, you are getting, just for example, 5,000 liter. So that is a 1 day limit. So you need to consider the minimum limit of 1 day and maximum limit of 1.2 times of daily limit. Okay, this is the regulation from Abu Dhabi I have shared. So similarly, if you go to Qatar Karama, as I mentioned here, Qatar Karama, the ground storage tank capacity should be sufficient for 2 days of water demand. So if you are getting 5,000 liter, what you need to do? You need to consider 10,000 liter as a ground tank storage capacity. So this is how the different regulations are giving us the idea to size the water supply tank. So there is a special classes in UAE. For example, if you go to the Abu Dhabi regulation, we can combine the tank. We can combine water supply tank. Sorry, please mute your mic. You can combine the tank of water supply tank as well as firefighting tank. Okay, so this is the special requirement in the UAE we are following. So, but there is a rule. That rule we have to comply. So, what the rule is saying here? The guide to water supply regulation from Abu Dhabi, the rule says that if the total required capacity exceed 3 times the average daily water demand, then a dedicated firefighting water reserve tank shall be provided. So let me tell you what they are exactly telling here. Okay, for example, okay, so here in this office building, you can see here, this office building, what they mentioned, 45 liter. So for one people in the office building, I need to consider 45 liter water capacity per day. So let's say we have a number of people, 150 people in our project from the architect seating layout or NFA 101. You have considered some numbers. So for the 150 people, the daily demand is 150 and you multiply with the 45, that is the water required capacity. It will be 6750 liter per day or 6.75 meter cube per day. So they are telling the 3 times of daily demand. So I multiply with the 3 times. So 3 times of daily demand is equal to 20.25 meter cube. Now let's come to the firefighting tank capacity. For the firefighting tank, let's say we have 500 GPM and the total water storage is 60 minutes. So the firefighting capacity is 30,000 gallons, which is equal to 113.6 meter cube. So now we got two answers. One is the firefighting tank capacity. Another one is the water supply tank capacity. Sorry, water supply tank capacity, 3 times of water supply tank capacity. So if you compare both, the firefighting tank capacity is higher. That is almost 5 times higher. So this time, this rule I'm not complying. But if the firefighting capacity is lower than 3 times of water demand, average daily demand, then that time only you can combine both water supply and firefighting tank. But in our case, what happened? The firefighting tank capacity is exceeded the water supply 3 times rule. So this time I cannot combine both firefighting and water supply tank capacity. I have to go with separate firefighting and separate water supply tank capacity. So as I told earlier, this rule is suitable for the UAE, but not for the Qatar. Qatar, we are normally using the separate tanks, like water supply tank separately and firefighting tank separately. So this is normally guided by the local regulations, not by the any international code like British code or international plumbing code, not like that. So we have to consider this requirement based on the local regulation. Okay, so when it comes to the next very important thing, the pumps. So pumps, what happened? When it comes to water supply system, the transfer pump, booster pump, circulation pumps, these are the important thing. So pump selection in commercial building, the water transfer pump are sized to fill the roof tank within a period of 4 to 8 hours. Okay, so this is a very common practical thing we normally follow to avoid the oversizing of the pumps. So how the things are saying for the commercial building, you need to fill the water supply. The tanks are located in the roof because the water transfer pump, what it is doing, it is transferring the water. It is transferring the water to the roof tank. So within 4 to 8 hours, it needs to transfer the water from the pump to the roof tank. That is for the commercial building. But when it comes to private apartments, the things are different. When it comes to private apartments, what happened? We normally expect the water filling time very fast compared with the commercial building. So it should be reduced to 2 to 4 hours when it comes to private building. Okay, so this is called as a filling time. So let's say one example how these things are working. For example, we have a roof water tank with the capacity 10,000 liter, and this is the residential building. Okay, residential apartments. So the filling time, as I told, it should be 2 to 4 hours. So what normally we consider in the mid like 3 hours we consider for the residential building. So 3 hours mean I need to convert to the second. So 3 into I multiply with the 60 to convert to the minutes. Then I multiply with the 60 to convert to the second. So total second is 10,800 seconds. So the pump capacity must be the total capacity, the water tank capacity 10,000 liter divided by 10,800 second. That is equal to 0.83 liter per second. Okay, so that is the capacity of the water transfer pump. Okay, so because sometime what happened, we have seen some projects. In the projects, the water filling time that people are considering very low, like 1 hour, 2 hour. That is very low. We normally don't recommend to do the over design in such a way. Okay, so because the concept is, for example, you don't have any water in the tank. Once the water is started filling, it will fill all the way till the flow to our limits. Then the water is completely filled. If you are using some fixer, what will happen? When you use some fixer, some amount of water will be dropped, but again the water will be refilled that time because of the floating wall. The water will refill. So the water will not go again to the zero level unless you drain the water. Okay, so that's the reason. Don't over design the transfer pump to make it very low filling time, like 1 hour, half an hour like this. It's very practical way to design 2 to 4 hours for the private apartments and 4 to 8 hours for the commercial building. Then coming to booster pump, this is again one of the very important thing we need to tell you here, because when it comes to booster pump, for example, we have a low-rise building project. We have a low-rise building project with the four-story buildings are there. The booster pump is located in the roof of the tank. From the roof side, from the roof tank, it transfer the water to the bottom floors. So what normally happens when we go for the design? Let me just tell you one small example. For example, we have a toilet here. Can you see my screen? Any issue?
No,
Can
it's
see, sir.
visible.
Okay, so for example, let's see, we have a toilet with a water closet. We have the wash basin. We have the bathtub. We have a bidet like this. So when the people are when the person is entering into the toilet room, in a single time, he cannot use all the sanitary fixture at a one time. So there is no concept, there is no logic to consider the sanitary fixture of all the toilets when you size for the booster pump. Okay, that will make the over design. Instead of that, actually the plumbing system overall, it's based on the probability. The plumbing system is based on the probability, and for even firefighting system also. But the HVAC system is not like that, because HVAC system in a single time the full rooms might it will function. But in the plumbing system, as I told, when the person is entering into the toilet, he will not use the water closet, bathtub, bidet, wash basin all at a single time. He will use either bathtub or he will go for the wash basin, like one by one. Things are like that. So this is like a probability of design. So when you go for the booster pump sizing, don't oversize the design by considering all the fixer at a time to make the pump sizing very higher. So what we normally consider, for example, let's say the same arrangement, water closet, we have bathtub. Just go to the International Plumbing Code or British Standard. You see what is the fixer unit they have given. I mean the highest fixer unit. For example, water closet has the highest fixer unit compared with the wash basin. Then you consider the highest fixer unit of each toilet. Suppose in our example, we have a 4-story. Each story we have 10 apartments. So there are 40 apartments total for that 4-story. So 40 apartments, each apartment, for example, we have 3 toilets. Each toilet don't sum all the fixer. Instead of you make the sum to all the fixer, just consider the peak demand. You can go to IPC. I will show you now in the coming slide. You can go to the standard. You can just select the peak demand sanitary fixer from the toilet, and you can size the booster pump. I will just ask you one question here. If you go to the high-rise building or super high-rise building, let's say, for example, we have a 20-story. I'll just write here. We have a 20-story building. You can just unmute your mic for a second. We have a 20-story building. I placed the booster pump in the roof. Okay. Normally, this if I place the booster pump in the roof, from the roof below to that one, how many floors normally the booster pump will supply? How many
Three.
floors?
Three rooms. 3 or 4 rooms.
Three floors.
Ah, 3 or 4.
floors.
Yes,
Three
correct.
floors.
Yes. So actually, what is the actual recommendation is, don't reduce the booster pump supply less than 3. Okay, that is the rule. It's like based on the practical experience, we will say don't reduce less than 3. Then you will face the issue for the pressure. Okay, so minimum 3 should be there. 3 is better. It's actually 3 is better. More than that, you can make the gravity flow. The gravity pressure will be sufficient. After that, you will provide the PRV. Okay, that's the second thing. So as you told, yeah, 3 stories better. So that is for the high-rise building. So in this case, to summarize this one for the booster pump, we will recommend to consider the peak demand based on the International Plumbing Code or British Standard or your local code, whatever you are following, for each toilet, and select the booster pump accordingly. When it comes to pipe sizing, now we talked about the tank, pumps, water booster pump, transfer pump. When it comes to pipe sizing, so when it comes to pipe sizing, we have, each design follow different velocity, because if you go to International Plumbing Code, we couldn't find the exact maximum velocity from that limit for different material. So this table, what I show you, it is from the American Society for Plumbing, ASP. American Society of Plumbing Engineering, okay, ASP. So this table will tell you something very logically. Like for example, if you go to the PVC pipe, 4 to 6 feet per second, we have to consider. The CPVC pipe, 5 feet per second. The polyethylene, the PE pipe, for example, HDPE, MDP, LDP, this thing 6 to 8 feet per second. So as if you go to steel pipe, normally for the plumbing, we don't use steel pipe. If you go to copper pipe, again, they are recommending 5, 8 based on different temperature. So it's a very practical way, and it is accepted by the British Standard or International Plumbing Code to use the plastic pipes like HDPE, PPR, UPVC. There are different kinds of pipes are there. Mostly we are using the plastic pipes in the Middle East for the water supply. So if you see this, the logical thing between the PVC and CPVC, the 5 feet per second is a logical value as a maximum velocity. So what normally it is recommended, the maximum velocity for the plumbing system should be 1.5 meter per second or 5 feet per second. The pressure drop should be in the range of 0.02 to 0.05 meter per meter. Okay, the unit is like that. Should be considered. You can size your piping for all the plastic pipes like PPR, CPVC, UPVC, even ABS. So all this one you can size based on this maximum velocity you can consider. Okay, coming to water heater sizing, actually this is like the quick sizing because when we inform you to register for the event, many people asked recommend some thumb rule type way. So this is like a thumb rule, but for the heater sizing, if you want actual thing, we normally follow the ashtray. We have the ashtray table. End of this webinar, we will send the table to all the registered people with some design documents also. Okay, so water heater, if you want to follow the quick sizing, if you have a toilet without bathtub, we will recommend to consider 50 liter. That is more than enough for a wash basin. Then if you have a bathtub also in the toilet, same toilet, you can go with the 80 liter water heater. If you have only kitchen sink, then you can consider the 50 liter kitchen sinks. Okay, similar to that, for the pipe sizing also, many of the people ask that please unmute your mic. For the next question, you please mute your mic. In the next question, you can unmute your mic, please. So for the pipe sizing, this is also we just would like to highlight one small like a thumb rule. For example, we have 20 pipes, we have 25 then we have the 32 So what normally follow for the 20 maximum 3 fixer you can follow. Maximum 3 fixer you can follow. For the 25 maximum 5 fixer you can follow. For the 32 maximum 10 fixer you can follow. So because this is asked by one of the 2-3 people asked the same thing, that's why I just added here in between the slide. So this is like a thumb rule. Then requirement of multimedia filter, water softener, and copper silver system. Because normally what happens in the plumbing system, in most of the project, in the commercial building and the industrial project, we can see this multimedia filter, water softener. All these things are comes in the plumbing system. So why it is required and when it is required, that is the basic thing. Because without knowing all, we just simply add the multimedia filter and water softener in all the project. There should be some logical way to consider the arrangement. So for example, I just consider the Abu Dhabi ADDC. So what happened ADDC? Now it is TACA. So water supply in Abu Dhabi, normally the hardness level, that is the important thing. You need to verify the hardness level. For example, you have a project in the remote area. There is no municipality water supply. You have to consider the tank water. So you have to have the tank water. From the tank, the water is supplied to the industrial project or commercial project. That time we cannot ensure the hardness level will be within the limit. But normally for the city project, if we are getting the municipality water, for example, if you see the Abu Dhabi, the municipality water hardness level will be less than 50 ppm, which is below the international standard requirements. So for the normal domestic water use, the hardness up to 170 ppm of hot water and 120 ppm of kitchen and laundry is acceptable. Therefore, water softeners are generally not recommended for the residential building project which receives the water from the local municipality. You need to verify the hardness level. Okay, if it is within the limit, we don't need to add the extra water softener for those kind of project. So for specific cases such as the steam boilers, where the maximum permissible hardness is less than 60 ppm, additionally you have to go with the water softeners. Okay, so it's very important that for your client is telling to add the water softener, we don't need to add water softener for all kind of residential project, because we are getting the municipality water which is already chemically controlled treated water, which has proper the pH value, which has proper hardness level. So in those kind of project, it is not recommended, but still I will tell you, I will add few more points here for your reference. Then this is for the hardness. Then it comes to suspended solids. This, in the most of the time, what happens? Normally, what happens when we go for the tie-in connection? For example, we have the building here. This is the existing line passing around the building. So once our internal testing commissioning is done for the complete building, we will make the tie-in connection with the existing. So what happened? The authority rule is that we have to make proper flushing. We have to complete our internal parts. Then we have to make the tie-in. In some cases, in some circumstances, if anyone is doing that one in the reverse way, that without completing the flushing chemical cleaning, if he connects with the external tie-in connection, what will happen? The suspended solids or whatever the things are there in his line, this will travel to the main municipality line. So this is the reason most of the project, the client itself recommends to have the multimedia filter to remove the suspended solids. Okay, so this is one of the important thing. Then the third and important, final, very important thing is the copper silver ionization. So the most of the projects we can see the copper silver ionization. We need to understand the practical reasons so why it is required. Because normally in the UAE or the Middle East, the cold water will easily reach 30-35 degrees Celsius, which lies within the bacteria growth range. So there is a bacteria called Legionella growth bacteria. So this bacteria, we need to understand the temperature, how it is when what temperature it is there like that. For example, 0 to 20 degrees Celsius, the bacteria will survive very easily, but it don't multiply. Okay, don't multiply. It will not increase the numbers, but it will survive in this temperature limit. 20 to 45, this is the very easy growth range for the bacteria. So this is the 20 to 45 is the very easy way we are getting the temperature in the Middle East. So this is not an easy temperature. It's not a good temperature we need to maintain. Because of this bacteria, we need to control this bacteria, and that's the reason we are introducing the copper silver ionization. And if it is 45 to 50 degrees Celsius, the growth will slow down. Instead of 10, it will be 2, but it will not be completely eliminated. It will be there. When the temperature is 50 to 60 degree, bacteria die slowly. When it is more than 60 degree, the bacteria are killed rapidly. That's a thermal disinfection zone we will call normally. So that's the reason normally the hot water is like it is stored in the temperature of more than 60 degrees Celsius. Okay, so this is the case. So copper silver ionization, what normally it is doing, copper silver ionization or CSI, it releases the controlled amount of copper and silver ions into the water. These ions penetrate the biofilm and kill bacteria. Okay. So CSI provides a residual disinfectant throughout the distribution system, killing the bacteria where thermal control cannot reach effectively. So in hot water system, if stored or circulated at 40 to 45 degrees Celsius, the bacteria will be there. That's why the storage tanks are maintained with more than 40 degree or at least 40 degrees Celsius. Okay, so this is one of the important thing. Now we understand when we need the multimedia filter. This is to remove the suspended solids. Water softener to prevent the scaling. Even if the local codes are maintaining the proper ppm level, some clients are insisting to go with water softener. As I told the reasons like that. Then CSI, copper silver ionization, to ensure bacteriological safety within the system. Okay, so these are the different kind of the things we are using for the water supply system. Now when it comes to pumps, so when it comes to the pumps, I have added a very quick selection chart for you. So actually in the coming weeks, we have a very detailed section which will provide how to select the pump curve and all these things. So this is like a quick reference for you to understand how to select the pumps. So pump selection, actually it is very simple. If you pick one wrong one, and it will remind you every day with noise, vibration and energy bills. So it is very important to select the pump very correctly. I have given one example here. You at the end of this one, you can answer me. Which pump you need to recommend for this flow rate and this head. Okay. For example, if you see the first tag number CWTP, that's a transfer pump located in the ground floor, which is transferring the water to the intermediate floors. Because now we are talking about the super high-rise building, so there will be multiple intermediate floors will be there. I will tell you how to select the intermediate floors and what are the limitations we have. So the very first thing, low head. As you see here, if you have low head and low to medium flow in your application, then what type of pump you can prefer? You can prefer the end suction single stage pump. End suction top discharge. That is a kind of pump. End suction top discharge centrifugal pump. Normally we are using for the chilled water and the booster pump applications. Then we have the low to medium head. So the head is slightly higher. I will tell you one example also. First, you can understand this one. Low to medium head, then the large flow. The flow is very high. Then what kind of pump we can go? We can go with a split case, horizontal split case. Mostly you can see in the firefighting, the horizontal split case pump and the condenser water pump for the chilled water. This thing. If the flow is very higher, head is only low to medium. Then you have the medium flow, the high head. Mainly for the super high-rise building, high head will be there and the medium flow will be there. So that time you can go with a vertical inline multi-stage, not the single stage. Okay, this is the important thing. Can anyone tell me what is the difference between single stage and the multi-stage for the pumps?
When the head increases, we need to use multi-stage pump.
Yeah, but what is multi-stage? What is single stage? It will be. It will have any extra bearing or what? What is there
It
in
will be
single
having
stage?
additional impellers.
Number of
Yes.
impeller increases.
Yeah. Yes, correct. Yeah, if you have only single impeller, it is a single stage. If you have the series of impeller, it can be 2 or more. That is multi-stage pumps. Okay, so if you want a higher head, you have to go with the multi-stage because single stage pump has a limitation. You cannot exceed that limit. I will show you an example now. So if you have the high head, if you have the medium flow, you can go with the vertical inline pumps. Okay, that is one of the best option. And medium flow high head again, but the layout, the horizontal layout, the location of the pumps layout, it is different. That time if you go, you can go with the horizontal multi-stage pumps also. Okay, so there are two options: vertical inline you can go, horizontal multi-stage also you can go. So both options are there. Now we will see one small example. The quick rule of thumb. What is quick rule of thumb? If the head is like more than 70 to 80 meter, which is a very common practice in the super high rise building, the head will be like 70 80 meter, very easily it will reach for the transfer pump. So if head is 70 to 80 meter, more than that, prefer multi-stage. Okay, so rather than single stage pump. If the flow is very high, like 300 to 500 meter cube per hour, 80 to 138 liter per second, which is the very common thing for the chilled water pump for the high rise building, this thing. So you can and the head is low to medium, but the flow is very high. You prefer the split case, horizontal split case pump. If you need compact footprint and a high head, you can prefer vertical inline multi-stage. What is compact footprint? I will tell you now with one example. If you need very high flow with a low head, you can prefer horizontal split case pump. Very high flow with a low head. If the head is less than 30 to 40 meter and the flow is high, the head is less but the flow is high, you can recommend the horizontal split case pump. If the head is 40 to 70 meters, slightly higher, the flow is low to medium, you can go with the horizontal end section pump. Horizontal end section pump. End section top discharge, that pump. If the head is higher, you can go with the multiple stage pump. As I told, the single stage pump has the limitation. It vary between manufacturer to manufacturer, but normally like if it is more than 80-90 meter head, then we have to go with the multi-stage. We cannot accommodate with the single stage. Okay, so based on the flow and head, we can select the type of pumps. So this is our example now. We have a 10.74 liter per second and the pump head is 150 meter. Can I go with horizontal split case? What is your recommendation, anyone? For the high head, low flow, medium flow? Which will be the correct one for these three pumps, transfer pump?
How many meters, sir? Head?
Head is 150 meter. Here you see is 150 meter I have mentioned here. And the flow is around 10 liter. Sorry?
Vertical inline.
Vertical inline, yes, that is a very common practice for the high head and medium flow. And that is not only the thing, there are some additional features also there when it comes to vertical inline pump, that we will see why it makes the things very positive way for the vertical inline pump. So this example, we can use the vertical, the head is very high. You see it is 150 meter head, that is almost 15 bar. 1 bar is equal to 10 meter head, so it is almost 15 bar. So we can use vertical inline multi-stage pump or horizontal multi-stage pump. Okay, horizontal multi-stage. Vertical inline is a preferred option for the high-rise, super high-rise building because it saves the floor area. That is when you talk about the sustainability point of view, this is one of the very important thing. If you go with the vertical inline pump, I will tell you one example also. Okay, so next thing. Now the important thing for the any super high rise building, how to select the mechanical floors. Because when it comes to super high rise, for example, you have 200 meter or 300 meter buildings are there. One pump cannot transfer the water till the top level. like 200 meter, 300 meter, one pump cannot transfer. There are some limitations are there. So that because of that limitations, we are limiting the pump. We are limiting the pump between the floors. We will not go with very single floors. For example, you have a 350 meter height super IRS building. If you keep one transfer pump and if you throw the water till the roof tank like this, the 350 meter height, that much high capacity pump we have to provide. That is not only the issue. The pressure rating of the pipe will go high if you select the 350 meter as a single time transfer pump. So that is the reason normally for AD super high-rise building, we will go with the multiple mechanical floors in between that one. So when we go with the multiple mechanical floors, we have to consider the pressure rating. We have to consider the pump maximum head like this. So how these things works? Okay, so I will show you one example here with the UAE code, UAE Civil Defense Code, then you can understand. So what this example say, this is for the firefighting. Okay, this is for the firefighting. So firefighting, what the limitation, I mean the maximum limitation, like you see in this arrow mark, fire water tank shall be provided for every upper level pump set at every 90 meter interval. So every 90 meter interval, there will be a upper level, the upper level pump set should be provided. So we need to limit here the total height. At every 90 meter, there should be one pump set should come. If pump set comes, mean there should be one mechanical floor should be there. Okay, so such water level tanks should be 30 minutes duration. This is related to the firefighting tank sizing. Now, in today webinar, we are not going deep into the firefighting design. We have some webinars in the coming days. We are going to discuss about the firefighting design. Okay, so this is the limitation I just want to convey with you. The maximum 90 meter intervals, you have to have one additional fire pump. It's not like you are keeping one fire pump in the bottom. The same fire pump cannot cover for the full height. Okay, so that is the limitation. So now we got one understanding about the pump head pressure from the firefighting. So when you are providing the mechanical floor for the firefighting, automatically we can use the same mechanical floor for the plumbing pumps also. So we can limit the height of the plumbing pumps. Second, pressure pump, plumbing pumps head. Second, to limit the pressure rating. Can anyone tell me what is the pressure rating normally we are using for the high-rise building pipes? Is it 10 bar or 20 bar or 30 bar? Anything?
10 bar or 12 bar. 12 bar.
10 bar, 12 bar. 16 bar. Okay. Okay, so
15.
okay, if you select the high pressure UPVC pipe, it will be class E. Normally in the Middle East, class E. It will be like a 15 bar pressure rating. Then you can go with the PPR pipes, SDR 7.4. You can go with the SDR 7.4 PPR pipes, which will PN 20 bar pipes. Or if you go with the UPVC pipe, class E 15 bar. So let's say that this has a limitation. So what is the limitation? If you say 15 bar, that is at to what temperature? Because every manufacturer will say our pumps are rated at 15 bar, but this is at what temperature? That is the issue. Actually saying this 15 bar rating, let's say we have the UPVC pipe, I'm going to use for my project. This 15 bar pressure is at a 20 degree. This is not for your feasible temperature limit. For example, if you are in the Middle East, your temperature will easily go 30-40 degrees Celsius. So you need to see the D rating. You need to see the D rating capacity for this pump, so for this pipe. For example, if you see this table, this is for the UPVC table. The 20 degrees Celsius, okay, it is there is no D rating. It is as it is. 25, no. When it goes to 30 degree, it is D rating is there, 0.9. You have to multiply your rating with this value. For example, let's say the Middle East, I consider 35 degrees Celsius very easily. So the D rating is 0.8. That means what? If the manufacturer says that the pressure rating of the piping is 15 bar, you have to multiply with D rating. That means it is only 12 bar. It cannot go more than that based on the D rating capacity. So you have to have this understanding for all the project when you go for the selection of the pipe. Okay, so that is the reason. In order to avoid increasing the pipe pressure rating, we are adding the multiple mechanical floors to reduce the pressure rating and also to see the authority regulations. Here in the UAE regulation, they consider every 90 meter intervals we have to have. So 90 meter means it is 9 bar. 1 bar is equal to 10 meter. So 90 meter means 9 bar. So if you select the UPC pipe with the 15 bar, even though you go with the D rating, Oh, that's even the safe limit. Okay, so that is the reason you need to consider the derating capacity. This will vary. This will vary for manufacturer to manufacturer. I have shown you only one manufacturer. When you go for your project, you have to consider the requirements. Okay, so this is
sorry
for
for
your,
interrupting. I have a quick question here.
sorry.
I have a small question here.
Yes.
Is this value cert? I mean, is it applicable for only UPVC or it can be used for any types of plastic pipes?
You mean the derating capacity?
Exactly.
Yeah, exactly. Actually, this derating capacity for all the pipes we have, CPVC, UPVC, HTP, all these pipes have the derating capacity based on the temperature. If you have normally the material submittal, the manufacturer will provide the sheet for the derating capacity. So you have to verify that derating capacity. This is not only for the building. Even if you go with any infrastructure project, this temperature is playing a major role, because infrastructure project, it is directly under the sunlight, a buried land. So there also the same things have to be considered.
Got it. Thank you.
Okay, so now this is just a snap from the UAE code for the super high-rise building project. As I told, this pump is there in the ground floor, then within the maximum within 90-meter interval. So we'll keep slightly 80 meters, something like that. Another pump will be there. Again, higher end, another pump will be there. So this will be, there will be multiple kind of pumps will be there in the serious way, like one by one in the limit. So what happens here? I just zoomed this picture for you. So here, if you see this this landing wall, normally for the firefighting tank, the water supply as per the UAE code from the firefighting system on from the firefighting system, there will be a line. There will be a line going to the firefighting tank. Okay, this is the very common thing. But in addition to that, we should have, or we must have the additional, the second way of water supply. Like you see here, this line, the supply line from transfer pump set. So there will be two way of supplies will be there for when you go for the higher floors. Like if you have three mechanical floor, each three mechanical floors has the, for example, the fire pump. So the one water supply from the water supply transfer pump, another supply from the firefighting itself. So there will be two kind of water supply you have to consider for the super high-rise building projects. Okay, now when it comes to the plumbing pump sustainability, this is what I told you. When it comes to sustainability, for example, you see we have different kind of pumps, horizontal split case, end section top discharge, vertical inline pumps. However, the vertical inline pumps will ultimately have superior performance in regards to sustainability, carbon footprint reduction, and space optimization and system efficiency. So why I'm telling particularly like this, if you see this right side image, the vertical installation requires, the vertical inline pump installation requires no pump room slab extension. Normally for the some kind of pumps, like left side you see, we have the slab extension also here. So if you have slab extension, the concrete volume will be there. So this will increase the carbon footprint in the project. So when you go for the vertical inline, you can reduce the footprint. You can reduce the footprint, and you can reduce means the carbon footprint will be reduced. So the foundation arrangement you can reduce, and even the piping arrangement, you can reduce inside the system, inside the pump room. So this is one thing. And when it comes to the pump, the pipes, when it comes to pipes wise, so what normally happens in the pipes arrangement, so you can see like hot and cold water, there are multiple pipes we have, PPR, UPVC, HTP, CPVC, there are different kinds of pipes we have. So the PPR, absolutely, the hot and cold water's suitability, it is excellent. UPVC, it is only for cold only, mostly, because the temperature limit for the UPVC pipe, normally we say maximum 60 degree maximum. HTP, limited hot use. So overall, if you see overall, we would recommend to go with the PPR pipes. Why? The reason why, for any kind of products, it is a very common thing in a sustainability point of view. You have to see the EPD. So many people are aware of the EPD. If you are not aware, if you are for side, this is the one of the important thing, and you can say it's a trend. It's a trend in the market now. You need to see the EPD, environmental performance declaration, for any kind of project, which will tell you what is the carbon CO2 level it produce from start to end. from the production of the pipe to the recycling, the full level, it will tell you the clear idea. For example, here I have compared the UPVC pipe with the PPR. For example, if you see the total carbon footprint, how much the PPR pipes are producing, let's say we have a super high-rise building project which uses the 17,000 meter of pipe. So for 17,000 meter of pipe, it will consume 9928 kilogram of carbon. That means 9.93 metric ton CO2 it will consume. If you go with UPVC pipe for the same capacity, it will produce 30.6 metric ton. That means you are saving 20.67 metric ton if you use PPR pipe. So this value how you take, you can take from the EPD. Normally the international manufacturer like a Hepworth, not Hepworth, I think some other manufacturer they have, like Aquatham, you know, Aquatham, the PPR pipes, they are in the very good way to produce the EPD for their product. Okay, this is one of the important thing. So for example, if you go with the manufacturing point of view, if you see the PPR, it will for if you want to manufacture 1 meter of the pipe, how much water consumption required when it comes to UPVC, you can save 34.5 meter cube of fresh water. And similarly for the recycle point of view, you can produce 100% recycle things with the PPR. So overall, if you compare the performance of PPR, UPVC, HDPE, CPVC, if your project is talking about sustainability and other thing, we would recommend to go with the PPR because of the CO2, water saving, and material recycle option. Okay, so these are the multiple things you can consider. Now, when it comes to cost optimization, how we go with the cost optimization for the plumbing system? Normally, when you go for the HVAC, we can say plenty of things, but when it comes to plumbing, we have some things to highlight here. So that's something actually, for example, we'll say we'll just say one bedroom house. We have a bedroom here, we have a toilet here, we have the living room, just for example. So normally what happened, the location of the shaft, the location of the mechanical or the drainage shaft plays an important role. If you say like a super high-rise building with 50-60 stories, so in one shaft, if you provide the location of the shaft in a wrong location or the long pipe routing, it will affect the complete project. How? Because for example, we have the toilet here. What we always recommend, to provide the drainage shaft inside the toilet. So this will reduce the pipe routing and plenty of things will be saved. For example, instead of providing the shaft here, if you provide the shaft at this location, your architect engineer is telling this is a feasible location for me to produce the shaft. So what you have to, then what you will do, you will run the pipe from the toilet to the shaft here. Otherwise you will take the rerouting, you will run like this to the shaft. So in this case, for example, if you choose this direction, how it will happen, you are running the pipe from the wet area through the dry area to the shaft. So if you are running the pipe through the dry area, you have to provide some additional requirements. So what are the additional requirements you have to provide? Sometimes it will make the noise, so you have to go with the acoustic logging. Some project, what they will say, you have to go with the GRP tray, leak sensor, leak detection cable. So there should not be any leak in the high-end projects, high-end VVIP projects. So you have to go with very high, means extra investment will be there. So it is always important to consider the design to provide the shaft, the drainage shaft, maximum inside the toilet, or just begin the toilet. Just begin the toilet. So this will save the pipe routing, this will save the pipe material, this will save the plenty of items. Like as I told, you don't need to go with acoustic logging, you don't need to go with this kind of thing like this. Okay, so this is one of the very important thing I will say when it comes to the cost optimization of the plumbing design. Yes. So anyone has any doubt?
Engineer, I have one doubt.
Yes.
Regarding that PPR RCT, some area I am seeing that RCT pipe. What's the difference between normal PPR and RCT?
Yeah,
It's
it
only
is
pressure rating.
No, it's not about only the pressure. It's not about the pressure rating. The PPR CT is the multi-layer pipes, not with the PPR. There are some additional layers are introduced in that PPR CT. So that is mainly for the noise. mainly for the noise, and the pressure. I mean the price will be high. If you say, I think the double price compared with the PPR, the PPR city is the double price, but the noise reduction is there. So actually there is one small comparison. If you say we have we have different kind of pipes. We have the low noise pipe, we have the soundproof pipes, we have the normal pipe with acoustic logging. So have you heard about the soundproof pipe? Anyone?
Yeah,
Soundproof
sure.
pipe?
Yes, yes.
Yeah.
Yes,
So
yes.
what is the thing?
Some of the
What it
managing.
makes the difference? Yeah, what it makes the difference if you go with the soundproof pipe?
I think the soundproof layer is more
Yes,
higher
correct.
compared to normal pipe.
Yes, so this is the comparison. You can see the low noise pipes, for example, noise reduction will be 4 to 10 dB. Okay, noise reduction. An acoustic pipe, if you go with acoustic UPC pipe, it will make 10 to 15 dB noise reduction. But if you go with a normal pipe with acoustic logging, 5 to 15 dB reduction will be there. So it will tell you how to reduce the noise. So for example, because you have a super high-rise building project, you have super high-rise building project with a 50 story, okay, 50 levels. 10 level you are using for the parking. Remaining 40 level you are going to use for the apartments. So if you want to make the cost optimization, if you think about the value engineering, what I will recommend you, you use the normal pipe. You use the normal pipe only for the podium and basement. Okay, wherever the parking is there, you use the normal pipe. But when it comes to inside apartment, I would always recommend to go with whether based on your budget. Again, it's based on your budget. I would recommend you to go with a low noise pipe or acoustic pipe. If you have a very good budget, I would say go with the acoustic pipe, or your budget is bit limited, I would say go with the low noise pipe, but not normal pipe. Normal pipe cost optimization is to use only for the podium floor. I mean the car parking area and even the soft. Okay, even the soft, but not for the inside building. So this is one of the important thing. Yes, any and just I want to ask one more. I want to add one more thing because many people asked this question in the class that in the registration link. When to use the velocity breaker? Velocity breaker for the high-rise building. Is there any rule, any code, anything that guide you to tell you that like this much floor we need velocity
Alternative
breaker?
floors, sir.
Ordinary floors? Sorry,
Yep.
alternate floors?
Yes, sir.
No,
But which
no.
regulation? But which regulation tell you like that? So there is no, it's not like no British standard, no IPC standard tell you to go with the alternate floors or every 3 floors. It's not like that. There is no rule like that,
Maybe
first of all.
vent
Sorry?
loop maybe every 3 floor. Vent loop maybe every 3 floor. Velocity breaker any specific requirement anything is there?
No,
No, I
there is
think
there is no rule actually. So
okay.
the practical thing is like first the velocity breaker, why we are using to reduce the noise, and water hammer in the stocks. So in a high-rise building, this is one of the important thing. If you have 50, 60 story, 200-meter height, the water will travel with very high velocity. So you have to provide the velocity breaker. But commonly it is a recommendation, but there is no rule. Again, I'm telling there is no rule. It's better to provide the velocity breaker every 5 floor. 5 to 6 floor. Okay, no need to make it every alternate floors. The limitations are there. What is the limitation? It's not only about the price. There is another limitation. Can anyone tell quickly what is the limitation to install the velocity breaker?
Space.
Sorry, size.
Space
Yes,
size.
space is the issue.
Right.
Because in the soft, we cannot say that the soft will be like 1 meter for the drainage pipe. In every drainage shaft, there is 3 kind of line is passing. What is that? One is like a soil pipe, one is the waste pipe, one is the vent pipe. It's the common thing in the each and every shaft. If so, in that shaft, we have to provide the access plug, we have to provide the vent pipe, we have to provide the velocity breaker. How many things you can provide in one shaft? You have to have the space. So velocity breaker every 5 floor is the feasible option that I would recommend, since there is no particular rule saying that every alternate floors you need the velocity breaker. Yes, so yeah, so any other question, because we are almost 1 hour is gone.
Yes, sir.
So we have covered today the plumbing system. In another means we will plan for the another webinar also to have the drainage system. One more thing, there are plenty of rules are there in the drainage system that we will cover in one more webinar in the coming days. So if you have any question particularly, you can ask me. Yeah.
I have a question.
Yes.
Yeah, regarding the intermediate mechanical flows, we have to provide the additional water tank, right?
Yeah, we have to provide, but the water storage capacity duration is low.
Yeah. What will be?
Sorry, what is?
What will be the duration?
Okay, for the main tank in the ground floor, I'm telling about the UAE. For the main tank,
Okay.
we are following 60 minutes. Main tank.
Okay. No,
All the
not for
mechanical
the
floors.
not for the firefighting, for the water supply.
Water supply, it's about the filling time only. You can keep the constant filling time. Yeah, as I told, the private 2 to 4 hours. The same you can follow for all the level, because it's overall one project. Every project, the water, in the project, the apartments, all apartment has to get the water in the same time. It's not like higher floor quickly, lower floor low. All time means for the full project we can follow same time of 2 to 4 hours, like 3 hours, 4 hours, like that. For the entire all the intermediate tanks.
Okay,
How many
understand.
service floors are there in Burj Khalifa?
Sorry. Sorry.
Burj Khalifa, sir.
Okay.
How many service floors are there?
I really don't know, but I have not worked with that project, so I don't have idea. But see, normally, if you have even a 400-meter height building, just for example, if you want to decide the number of mechanical floors, as I showed you, you can divide with the 90. 90 is the maximum. You can divide with the 80. So there should be at least 5 mechanical floors. So you can consider the Burj Khalifa accordingly. So how much it will be there? There are some limitations also there. As I told, the pipe pressure routing and the mechanical flow. But this is the concept. Okay, this is the concept. If you say even if you have 300-meter building, you can say maximum 80 meter. There will be 3.75. That means 4 mechanical floors you have to consider. Yeah. Okay. So any other question,
Sir,
or we
can
will?
I ask you one more doubt?
Yes, please. Yeah.
So you said every 90 meters we are providing one mechanical floor, right?
Yes.
So
Yes.
in that mechanical floor, are we providing any tanks in there, or we are just providing that booster pumps, multi-stage booster pumps only?
Okay, the water has to go to the tank only. So we have to have the tank there. Every mechanical fluids, water supply tank as well as firefighting tank, both has to be there.
So,
You can combine, as I told.
so
Yeah.
what will be the size? Like overall, we will have a overall we will have like X meter cube of water should be there in the tank as backup or storage. But on intermediate 99, let's say 90-meter floors, we are
Okay.
providing what should be the size of the tank should be.
Yeah.
Like,
Okay. So
what
see, let's
percentage should
see.
be considered?
Yeah, understand. So we have let's say that we have the 100-story tower. So this is one mechanical floor. This is one mechanical floor. This is one mechanical floor, for example. So you have the tank here. You have the pump here. You have the tank. You have the pump like this. So from this tank, there will be a booster pump. As you people told, it will supply to first 3 floor. Okay. Then balance floor, this will supply through the gravity. I mean, from here there will be a gravity. Same way here, first 3 floor booster pump and bottom will be gravity. So whatever you need to find out the people quantity of this much floors that you need to add for this tank sizing. You need to find out the people quantity of this much floor that you need to add for this tank sizing.
Okay, noted. Thank you.
Okay, so that based on the number of people, you can size the tank. How much floor it is supplying, that much. Yeah.
Okay.
Okay. So okay. So thank you all for attending the webinar. So today we have just We just discussed some technical aspect of the tank sizing for the super RS building with water supply.
Mr.
Yeah.
Nagaraj,
Yes.
can we have the video, recorded video? Because I was in hospital, I could not hear some of the.
Yeah, we will upload. We will upload in our YouTube channel. Yeah, we have the TIECONN channel. We will upload in our channel next week. Yes.
Okay.
Okay, fine. So, yeah, so thank you again, once again, for joining us today for this webinar. So as I told, we have covered the plumbing system. I mean, the water supply today, like the tank, the pump, transfer pump, booster pump, and the quick rule for selection of the pumps, with the quick rule for the pipe sizing and the water heater, and some additional recommendations for the super high rise building. And it's not only that, we have today we covered only the water supply. We are planning for another webinar in the coming days for the drainage system, because not only the plumbing, the drainage has plenty of limitations we have when it comes to super high rise building. What kind of fittings we need to use, where we need to provide, where we should not provide. There are some no connection zones. There are some limitations are there. How to terminate the how to make the routing for the super RS building. So we will arrange one more webinar for the drainage system also. So thank you for your support once again. Have a great day. Thank you.
Thank you.
Thanks, boss.
Thank you.
Thank you, sir.
Yeah. Thank you.
Thank you. Thank you so much.
Thank you.
Thank you. Yes.